Alright, we did absolute value equation. How about absolute value inequality? There are two types of absolute value inequality. One is okay and the other is hard. As a matter of fact, I take it back. There are more than two types. There are more. There are two types of absolute value inequalities if you have just only one absolute value. But if you have more than one absolute values, then each absolute value has its own ramifications, so you're going to open a floodgate. But even with only one absolute value, you have one that's okay and another that's not so okay. Let's consider okay case. Absolute value is less than some other expression. In that case, absolute value goes in the middle, and then maybe you can do something relatively easily. And this one was for strict inequality, that one was for semi-inequality. So even though we have two forms, basically we are talking about only one thing. Now, when absolute value is greater, then that's difficult. P of x is greater than q, or p is less than negative q. And then we have to get the solutions done and then think about what the heck does it mean by or. My decision is to skip this topic altogether. Our textbook author does relatively good job explaining it. Yes, that's true. But then again, I thought, when are the students gonna be needing these? Some of these will come back in calculus too, but most of the students here are not heading that much high. And things like these, not even there. As a matter of fact, when you have to teach, then you have to, teach yourself again. Otherwise, they don't really appear. So, hey, why would I bother with all these kind of things? So let's just stick to something that is related to the graduation plan, basically, calculus track. And I'm confining myself only to these kind of examples. Absolute value less than a number, sometimes absolute value less than some relatively trivial x expression. But in this case, they're both just numbers. So how do we work out? Let's open up. They're both in this blue case, right? So negative 7 and then 2 minus 3x over 5. That expression, and then positive 7. It falls into this. And then let's remove the denominator. Multiply by 5, negative 35, 2 minus 3x, positive 35. It's kind of tempting to stop here, but let's do one more. Let's remove this 2 to the other side. So negative 35 minus 2, 35 minus 2. I just subtracted 2 from all three, and then minus 2, and then here cancelled out, and then there we have minus 2. So in the end, negative 37, negative 3x, 33. Almost there. Let's divide each by negative 3. So negative 37 divided by negative 3, negative 3x divided by negative 3, and 33 divided by negative 3. All good? No, not good. What did I do wrong? I have to flip the order of these inequalities because I just divided by a negative number. Now everything looks good. 33 divided by 3 is 11. Oops, what's this? Typo, sorry about that. And this is perfect if this is just solving an inequality, but if you want the interval notation, I'd like to change it into a little bit more standard form. Lower number goes to the left, higher number goes to the right. And then express it as an interval notation. So once you change this inequality into that, it's easy. Follow the same process. Denominator, parentheses, like terms. You can't miss it. Denominator, parentheses, like terms. Keep that in your mind. You can't miss it. Second problem, I'll leave that to you. All you have to worry about is nothing to worry about, as a matter of fact. Just semi-inequality, so we have bracket. That's about it.